Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 6, 6.4, and we're looking at integration by parts. Integration by parts is derived from the product rule for differentiation, which is that if you differentiate the product of two functions, u and v, you get the first function u times by dv dx plus the second function v times by du dx. If I rearrange that, then I can get u dv dx is equal to d by dx of uv minus v du dx. And then I integrate both sides of this equation with respect to x. That gives me that. This middle term here is the integral of the differential of uv. Well, integration and differentiation are inverse functions to each other, so these two just cancel each other out. And this simplifies to the integral of u dv dx with respect to x is equal to uv minus the integral of v du dx. And that is integration by parts. It's the formula that you will have to use. The general idea is that we're integrating the product of two functions, one of which we're going to need to be able to integrate. That one will be dv by dx, and the other of which we need to be able to differentiate, and that'll be u. And frequently, we choose u, the function that we're differentiating, to be the one which becomes simpler when it is differentiated. Now let's have a look at how this works out in an example. So we've been asked to find the integral of x sine x dx. Now questions, normally you will have to choose which of these two things is u and which of them is dv by dx. They won't tell you that in the exam. Now what we're going to do on this question is we're going to let u equal x and dv by dx equals sine x, but they don't have to be in the right order. It could have been the other way round. The reason why we've chosen u to be x is that when I differentiate this, it becomes simpler. But if I were to differentiate sine x, it just becomes cos x. It doesn't become simpler. So that's the normal rule of thumb. So u is x. That means du by dx, if I differentiate it, as I say, it becomes simpler. It just becomes 1. dv by dx we need to integrate, and if we integrate that, we'll get v equals minus cos x. We now know all four things that we need to know in the equation. So you'll substitute in for u, v, and du by dx. You'll have to carry out this integral in the normal way, and then you'll have completed the question. Doesn't take very long, this question. I'll let you have a go at doing it yourself. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look at this. So we are just substituting in for u, v, and du by dx. U, that's equal to x, so we've got x here. V, that's equal to minus cos x, we've got minus cos x here. Take away the integral, v again, which is minus cos x again. Du by dx is just 1, so when I times by 1, it stays as minus cos x. That gives me minus x cos x when I multiply out these brackets. And if I integrate minus cos x, I get minus sine x. And tidying that up gives me the answer. Minus x cos x plus sine x plus some arbitrary constant c. Okay, example 2. Find the integral of x e to the x dx. And again, we'll choose u to be the function that becomes simpler when you differentiate it. We'll choose dv by dx to be e to the x. This we need to differentiate. This we need to integrate. Then you substitute all four things into the formula. Have a go doing that yourself. Pause the video. Come back to me when you're ready. Okay, let's have a look. So as always on these questions, we need to differentiate u. That gives us du by dx is 1. We need to integrate dv by dx. That gives us v is equal to e to the x. Then we substitute all four things into the formula. And that gives us x times by e to the x minus the integral, and you get e to the x for v, and du by dx again is just 1. So when we multiply by 1, it is just the integral of e to the x. And we can immediately write down the answer. That's x e to the x. When I integrate e to the x, I get e to the x plus some arbitrary constant. Example 3 is a special case, but it is one that you're expected to know. And it uses a neat trick which turns up on a few questions similar to this. It looks like we've only got one function, and integration by parts requires two functions multiplied together. Well, we can change that into two functions multiplied together by saying the integral of log x is the integral of 1 times by log x. And then we choose to let u equal log x and dv by dx equal 1. Okay, I'll let you have a go at pressing on from there. We can't integrate log x, which is why there's a problem with this question, but we can differentiate it. When you differentiate log x, you get 1 over x. Anyway, have a go at finishing the whole thing. Pause the video, come back to me when you're ready. Okay, let's have a look. So differentiating u, that gives us 1 over x. Integrating 1, that gives us v is equal to x. Substitute all 4 things into the formula, and that gives us log x times by x minus the integral of x times 1 over x. And now you can see why we chose to do things this way around. X times 1 over x simplifies so that we've got x log x minus the integral of 1 with respect to x. And that just gives us x log x minus x plus some arbitrary constant. Okay, example 4. Integrate I equals the integral of x squared cos x dx using integration by parts twice. And the reason why we need to use integration by parts twice is because of this x squared term. We're going to choose it to be u. When we differentiate it, we'll get 2x, but we'll still have an integral that we can't do when we've done that. However, we can then choose to let 2x equal u, and we integrate by parts a second time. I'll let you have a go at seeing if you can make sense of that. So pause the video. You have to use integration by parts twice, and then come back to me when you're ready. Okay, let's have a look. So it starts off as normal. We're going to let u equal x squared. We're going to let dv by dx equal cos x. Differentiating u gives me 2x. Integrating that gives me v equals sine x. Substituting those into the formula gives me x squared times by sine x minus the integral of sine x times by 2x. Now the problem this time is what we have here is still something we can't just automatically integrate. But we can integrate this by parts. So what we'll do is we'll let u equal 2x in this integral and dv by dx equals sine x. That means du by dx is 2. Integrating that gives us v equals minus cos x. Substituting all 4 things into the formula just for this integral here gives me x squared sine x minus, and then this becomes 2x times minus cos x minus the integral of minus cos x times by 2. Now, we just have a constant times by cos x here. That means we have an integral that we can find. So that's where we got so far. Simplifying this on the right-hand side gives us x squared sine x minus, and then minus 2x cos x minus the integral of minus 2x minus 2 cos x. Now, one thing to note here, these brackets are really important, and you do need to walk carefully with minuses. There are an awful lot of minuses in this question. Minus 2 cos x we can now integrate. So integrating that gives us minus 2 sine x, and tidying up these first 2 terms gives us that. And then tidying up the plus and minus there gives us the answer. The I is equal to x squared sine x plus 2x cos x minus 2 sine x plus the arbitrary constant c. Okay, example 5. This is very similar to the last example, but there's an additional problem, which is that neither term simplifies when you differentiate it. However, there is a little trick that we're able to use that means we can still use integration by parts twice and get to the answer. Now we'll begin by letting u equal e to the x and dv by dx equal cos x. When we do that and substitute into the formula, we still have an integral that we need to integrate by parts. So we'll integrate by parts a second time. And then a very useful thing happens. I'll let you see if you can work out exactly what that useful thing is. So pause the video, have a go at working your way through this, and then come back to me when you're ready. Okay, let's have a look. So u equals e to the x. As always, we need to differentiate that. That'll give us du by dx is e to the x. Integrating that gives us v equals sine x. Substituting into the formula gives us I equals e to the x sine x minus this integral, sine x times by e to the x. This we integrate by parts again. So we let u equal e to the x in this second integral, dv by dx equals sine x. That means du by dx is equal to e to the x, and v is equal to minus cos x when I integrate that. Substituting these into the second integral gives us e to the x sine x minus all of this, which is e to the x times minus cos x minus this integral. So that's where we've got so far. This integral here, when I take away the brackets, when I walk carefully with the minuses, it gives me this, that the integral I'm trying to find is e to the x sine x plus e to the x cos x minus this integral. Now, this integral is the question. So we were asked to integrate e to the x cos x right back at the beginning. This integral is equal to I. That means I can just substitute I for this integral because that's where we started from. It's equal to I. So substituting in I gives us the integral, I that we're trying to find, is e to the x sine x plus e to the x cos x minus I. Moving I to the other side gives us 2 times I is equal to e to the x sine x plus e to the x cos x. And now I can write down what I equals. It'll equal a half of this. So e to the x over 2 and sine x plus cos x in brackets, if I factorize it, plus an arbitrary constant c. Okay, last example. The only thing that's different on this example is we've been given limits to use for the integral. So we're trying to integrate this between x equals 2 and x equals 4. And we've been asked to give our solution in the form some constant times log 2 minus some other constant. We'll let u equal log x, and we'll let dv by dx equal x cubed. Okay, have a go at working your way through this. You just use the limits in the normal way. So pause the video, see if you can make sense of it, and then come back to me when you're ready. Okay, let's have a look. So u equals log x because we do know how to differentiate log x. If I differentiate log x, I get 1 over x. dv by dx is x cubed. If I integrate that, then I'll get v equals 1/4 x to the 4. Substituting all of that into the formula gives me that. The only thing I need to be careful with now is I need to use the limits. So this first expression here, when I substitute in, I get log x times by 1/4 x to the 4. I do need to use the limits x equals 2 and x equals 4 for that expression. And then I've got take away this integral with the normal limits still there. Tidying up this here, 1x cancels from the top and bottom, which gives me the integral of 1/4 x cubed. That's where I've got so far. Carrying out that integral gives me 1 over 16 x to the 4, and I put in the limits in the normal way. So I need to calculate this in the normal way, calculate this in the normal way. Putting in 4 gives me that, putting in 2 gives me that. Take away, putting in 4 gives me this, putting in 2 gives me this. Now, in a sense, that is the answer, but they've asked us to do a great deal of tidying up to get the answer in a very specific form. So here, 1/4 times 4 to the power of 4, that's 64. 1/4 times 2 to the power of 4, that's 4. This all simplifies to 16, and this all simplifies to 1. Now, log 4, I'm going to choose to write as log of 2 squared, because then I've got log of the same numbers here. And that was the form they actually asked for the answer in. And this I've tidied up to 15. Using the normal rule for 1,000 logs, the 2 comes down to the front, and I get 2 times 64 is 128. And then that simplifies to 124 log 2, take away 15, and the answer is in the form that they asked for. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 80 and have a go at exercise 16. Thank you very much for listening, and cheerio.